melting points of the oxides as part of the periodicity for the period 3 elements. So you can see that there are 3 ionic compounds, 1 giant covalent compound and 2 simple covalent compounds. So the melting points of the oxides vary based upon their structures and bondings. The ionic oxides are sodium oxide, magnesium oxide and aluminium oxide. The ionic oxides have high melting points because they have strong electrostatic forces of attraction between the oppositely charged ions in the ionic bonds. And you should know that from Unit 2. Magnesium has a higher melting point than sodium because magnesium has a +2 charge, which has a greater electrostatic force with the -2 oxygen atom, and this is greater than that of the +1 charge of the sodium. Aluminium oxide, however, has a lower melting point than we would expect, and this is because the +3 charge on the aluminium polarizes the anion, which is the oxygen, and this causes there to be covalent character within this bond, and these covalent bonds are weaker than the ionic bonds because they're only partial. So silicon dioxide has the highest melting point of the non-metals, and this is because it has a macromolecular structure, and this is made up of strong covalent bonds. Finally then, we've got the phosphorus 5 oxide and the sulfur dioxide, and these have the lowest melting points, and this is because they have only simple molecular structures. This means they're only attracted by each molecule by weak van der Waals forces and dipole-dipole intermolecular forces, and these only require little energy to be broken, so therefore they have low melting and boiling points. And that's it for this short video on the melting points.